Yesterday when I gave you your syllabus, we defined physics loosely as the study of matter, which is this desk, this paper, this person, the study of matter, the study of energy. Energy is the ability to do work, and the interaction between the two. That's a pretty big definition, though. It encompasses a whole lot. It includes a unit that we call kinematics, and that's what we're going to focus on for the next few weeks, kinematics. Kinematics is what you did in Science 10, at least a little bit of kinematics. Kinematics we're going to define as the study of motion, the study of motion. But the next unit, dynamics, is also the study of motion. So what's the difference? Well, kinematics is the study of motion without regard to what's causing that motion. So in other words, we're going to pay attention in this unit to the motion itself. We're not going to pay any attention to what causes the motion. Does anybody know what causes motion? At some level, you guys do know this. You've heard this word a million times before. What causes motion? What do you got to do to get something moving? Yep. Kinda. It's not what I was looking for, but yep. Force. Force causes motion. So in other words, in this unit, we're focusing on the motion itself, but not the forces that cause the motion. In the next unit, dynamics, we're looking at the motion, but paying specifically attention to the forces that cause the motion. So we're going to say that kinematics is a study of motion, but we're not going to pay attention to the forces. There's forces there, right? We're just not going to pay any attention to them. Now, this is a little bit of a review from last year. I know that you've defined these last year, a vector and a scalar. Does anybody remember the difference? How many of you guys took Science 10 in semester 1 last year? Oh, that's like a year ago, hey? Although physics you did last, I think, so it would be more like 6 months ago. How many people took it semester 2? Okay, you guys, it was like 3 months ago that you did physics, right? 2.5 months ago. Anybody remember? Yep. Yes. A scalar is a quantity with just magnitude. So in other words, not only do we not pay attention to the direction is irrelevant. There is no direction associated with a scalar quantity. So we're going to say a scalar is a quantity with only magnitude. You guys know what that word means, magnitude? Like size, amount? If I'm moving on the highway at 100 kilometers per hour, the magnitude of my speed is 100 kilometers per hour. My mass is about 70 kilograms, so the magnitude of my mass is 70 kilograms, the amount of it, right? A vector, you told me, I think, is a quantity with magnitude and direction. I don't know about you, but when I was younger, I would always remember that one of them has magnitude and one of them has magnitude and direction, but sometimes, I got a bad memory for stuff like this. Sometimes I would get them mixed up, confuse them. I would know what they were, but I would just mix them up and get them backwards. And then one day, several years ago, I was grocery shopping with my wife. And I don't really like grocery shopping too much. So I usually just try to entertain myself some other way by, I don't know, like sometimes I just watch people and see how odd people behave, which you might argue that watching people is an odd behavior in itself, but sometimes I just see how oddly people behave. Sometimes I read things and just whatever. This one day I happened to be just reading labels in the cereal aisle. And I came across, I don't know if you guys have ever had this, vector cereal. You guys ever had this? I came across vector and I'm like, you know, they call it a meal replacement, not a cereal. It says on the front vector meal replacement, not vector cereal. And I thought, I wonder if it's any different. Like, I wonder if it's any different than, like, say, cornflakes nutritionally. It's not very much different, by the way. It's almost exactly the same nutritionally as like cornflakes. It's all marketing. But what struck me that day, a number of years ago, was that Vector cereal, or I should say Vector meal replacement, was the only cereal in the entire aisle. Get this. The only cereal in the entire aisle. They all have the size of the box, right? This is 400 grams. That's the magnitude of the box. They all say that. They have to, right? So that you know how much you're buying, how much you're paying for how much you're buying. Okay, but Vector cereal is the only one that actually gives you on the side of the box directions for use. Just in case you didn't know how to use this, it gives you directions for use. What does it say? Place 55 grams of Vector in a bowl. Add 200 mils of milk. You guys got that? Place in a bowl, add milk. Then what? Doesn't say what to do with it next. I don't know. But what struck me is that Vector cereal, like every other cereal, has magnitude. Vector cereal has magnitude and direction. Not the kind of direction we're talking about, right? Like not direction like north, south, east, west, which is really what we're talking about here, right? Like if I give you a quiz and say, give me an example of a vector, don't say cereal. Okay, don't say vector cereal. But it's a way, it's not a vector, but it's a way to remember the difference between a vector and a scalar, right? Vector has magnitude and direction, right? The only one in the entire aisle. Scalar has only magnitude. Does that make sense? By the way, I bought the cereal that night. This is it. I don't remember exactly when it was, but it's a while ago because this expired November 13th of 2003. So if anybody's thinking about stealing my cereal, you might want to reconsider that. Maybe go by. Is anybody a hockey fan here? Well, this gives it perspective here. Curtis Joseph is on the back of the box. That tells you how old this box of cereal is. So a vector is a quantity with magnitude and direction, whereas a scalar has only magnitude. Good? Okay, this is the meat of today. This table is the meat and potatoes of today. I want to define some terms, some of which you may be a little bit familiar with already. I want to give you the symbol for them, the units, like kilometers per hour for speed kind of thing. And then we want to distinguish whether each of these are a vector or a scalar. And then we want to be able to find some of these variables, and then we'll call it a day. We're going to define distance quite simply as how far something has traveled. Or how far something travels. That's it, right? That's a pretty intuitive definition, right? I'm standing right here, 2 meters. Listen carefully. I'm standing right here, right now, 2 meters from the front of the room. Now I'm standing 8 meters from the front of the room. What's my distance? What distance did I travel there? I was 2 meters, now I'm 8 meters. What's my distance traveled? 6 meters. How far something travels, how far I traveled? 6 meters, right? Right? Now, the symbol for distance, sometimes we use a D, but more often we use a little triangle D. Do you guys know what that triangle means? Yeah, it's a Greek letter called delta, and it means change. So we usually use this one because when we're talking about a distance traveled, we are talking about change, right? If I moved, I changed. So the typical symbol would be delta D rather than D. Now, there's all kinds of units we can use for distance. Kilometers, miles, centimeters, inches, light years. What units do you think are the standard unit for distance? the one that we're going to use the most often. The one that we would say, if in doubt, go with this one. What do you think it's going to be? Meters. There are lots of times that you can use units other than meters, but there are some times when you must use meters, when you have to use meters. I'll point out when you can use whatever units you want and when you have to use meters, but in the end, if in doubt, if you're confused about what units to use, what should you do? Just use meters, because they're always going to work, right? Meters are always going to work. Other units will sometimes work. Meters will always work. Now, do you think distance is a vector or a scalar? It's a scalar, yeah. I walked 6 meters in that example that I gave you, right? Not 6 meters north. I mean, I might have walked 6 meters north, but I didn't express that. My distance was just 6 meters. It's going to be a scalar. Man, they're thinking, physics is easy. This isn't hard at all. It gets a little harder, but not much. Let's define our second term here. Position. Position is a location relative to something. There's a couple differences here. One, it's relative to something. Distance isn't, right? Distance is just, this is how far I went. My position has to be relative to something. I'm 2 meters from the front of the room. I'm 2 meters north of whatever. I'm 30 kilometers south of Calgary, relative to the front of the room, relative to Calgary, right? But it's also not how far something's gone, it's where something is, right? Think about that. A location is not how far it's gone, but where it is. Where am I? I'm 30 kilometers south of Calgary. It's not how far I've traveled, it's where I am, my location. Does that make sense? Now the symbol for position is D with a little half arrow over top of it. You guys seen that symbol before? That little half arrow symbol? Anybody seen it before? How many people have seen that before in Science STEM? Okay. What does it mean? Yeah. Yeah, it means that it has direction. If it has direction, then that means position is a, what is it? Somebody said it? Vector, yeah. So let's call it a vector right now. The units for position are going to be, well, could be kilometers or inches or whatever, but the standard units are going to be meters again. So, if I am 2 meters, let's say that there's the front of the room. This is north. Okay, if you look out at 32nd Street there, you know this way is north, right? So right now I'm 2 meters north of the wall. 2 meters north of the wall. Is that a position or is that a distance? 2 meters north of the wall. Position. That's where I am, right? That's where I am. That's a location. It's not how far I've gone. 2 meters north of the wall. Okay? Now I am 8 meters north of the wall. Is that a position or is that a distance? That's a position. That's where I am. That's my location, right? Where I am. 8 meters north of the wall. What's my distance in there again? 6 meters. 6 meters north? No, just 6 meters, right? Because distance is a scalar. Got it? So you understand the difference between distance and position? Where I am, my location, versus how far I've gone. Okay? All right. Displacement. Displacement is defined as my change in position. The change in position. Oh, man, it's close to position, but it's the change in position. Anybody want to take a stab at what the symbol for this would be? You guys can get this. I know you guys can get this. The change in position. Yeah. Is it John? CJ. Yeah, yeah. We're going to say delta D, change with a little arrow over top of it. Position is D with the arrow. Change of position is delta D with the arrow. Units would be meters. Vector or scalar? It's a vector. You know that because it's dependent upon position, but you just look at the symbol, right? The symbol has a little half arrow over top of it. It's got to be a vector. Now, time. Actually, let me give you an example of displacement here first. Let's go back to the example that I was doing a minute ago here, okay? I'm 2 meters north of the wall. That's my position, right? My initial position. Now I'm 8 meters north of the wall. That's a position as well, right? My 8 meters north. My distance was 6 meters. What's my displacement in there? When I went from 2 meters north to 8 meters north, my distance was 6 meters. My displacement is, nope, 6 meters north. Got it? Does it make sense? My final position was 8. My initial was 2. My change was 6 meters north. All right? Let's do another one here. Let's say my initial position is 2 north. Then I go to 8 north. Listen carefully. 2 to 8. And now I'm going back to 4 north. So I walked north, and then I walked south. 2 north was a position, 8 north was a position, and 4 to the north is a position, a location, right? Does that make sense? What's my distance traveled there? What's my total distance traveled? I went from 2 to 8, which is 6, and then I went back from 8 to 4, which is 4. My total distance is, Nick? 10 meters. Make sense? Yes? What's my displacement? Oh, good one. My displacement is not 10 meters north. It's 2 meters to the north. Because my final position is 4. My initial position is 2. My change in position is 2. 4 minus 2 is 2. Does that make sense? We'll give you some examples written down, so don't panic about this if you think you might forget it. Yeah?
When I was in science 10,
Yep.
the teacher said that displacement is kind of like as the crow flies.
Yes?
So it's like the straight line between the two.
Yep, yep. No, that's a good way to put it, as the crow flies. So your distance, my distance, like when I went from 2 to 4 there, right? My distance was 10 because I kind of went out of the way to get to my final position, right? But my displacement was just final position minus initial position, which is, yeah, as the crow flies. Good. Yeah, that's a good way to put it. And finally, time. Man, I'm not going to define time. Like, you look up time in the dictionary, like, you're not going to find a good definition for time. Time is that thing that, listen, we all know what it is, right? Everybody knows what time is. But I challenge you to come up with a good definition for time. I can't. I've tried. Like, what is it? Like, how do you define time? We all know what it is, so we're not gonna. We're just gonna leave this one. We're just gonna leave this one blank. The symbol for time, I'm going to say T or delta T. If we're talking about, hey, what time is it right now? It's 10:09. That would be T. How long does this class last? 57 minutes. Oh, that would be delta T, an interval of time. Does that make sense? So a specific moment in time, look at your watch, that's T. How much time has elapsed would be delta T. Usually, we're going to use this, delta T. That's almost always what we'll see. Units? Yep. Seconds. Like, sometimes you can use hours or days or minutes, but usually it's going to be seconds. If in doubt, go with seconds. And is it a vector or a scalar? It is 10:09 to the north. Does that make any sense? Well, then time must be a scalar. Now, I'm going to show you two quick ways of finding displacement. We'll do a couple quick examples, and then that'll be it for us. Give you some questions to work on. That'll be it for us for the day, for the week. So now, to find displacement depends upon what we've got given to us. To find displacement, if we're given positions, remember what's the symbol for position? Quick, symbol for position? D with the arrow, okay? If we're given positions, we're going to say it's final position minus initial position. Remember, it was the 4 meters north minus the 2 meters north, gave me a displacement of 2 meters to the north. Final position minus initial position. But the other way of finding displacement, if we're given different variables, looks a bit different. If I said I walked 10 meters north, and then I walked 3 meters to the north, I wouldn't subtract, would I? I'd add. If we're given positions, we subtract. If we're given displacements, we add. So what you got to do is decide, what am I given? Am I given positions? Am I given locations? If I've got 2 locations, then you should subtract them. If I'm given 2 displacements, 2 changes in positions, then I'm going to add them. Example number 1 says, you walk 20 meters east, then you walk 10 meters west. What's your distance and what's your displacement? Well, distance isn't very hard right now, right? What's my distance traveled here? I walk 20, then I walk 10. What's my distance traveled? 30 meters, right? Got that? 30 meters. Now this is displacement is a little bit harder here. What's my displacement? Remember, there's 2 ways of finding displacement, right? It was either subtracting or adding. I subtract when I have positions. I add when I have displacements. What do I have here? I walk 20 meters east. Is that 20 meters east? Is that a location? Or is that how far something's gone? A change in location. That's a change, right? I walked 20 meters, and then I walked 10 meters. Those are 2 displacements, right? Am I going to subtract or add? I'm going to add. Right? So I'm going to say my displacement is displacement 1 plus displacement 2. If I said I am 10 meters east, and then I'm 20 meters, or I'm 20 meters east, and then I'm 10 meters west, then I would subtract. If I have locations, I subtract. But if I have displacements, I add. So let's do this here now. We say displacement number 1, we're going to say is 20 meters. Displacement number 2 is 10 meters. Is that right? 30 meters? How do you think I distinguish this? I don't like words, by the way. I don't want to distinguish with words, east, west. Yep. Yeah. Let's make east positive. And if I do that, then displacement number 2 becomes negative because it's west. 20 plus negative 10 gives me 10 meters. But it's positive 10. So my displacement is 10 meters to the east, somebody said. Make sense? Does that make sense? You're going to see in the next question, there's only one more, but you're going to see in that last question the difference between displacements, adding, positions, subtracting. So our last example says, my initial position is 100 south. My final position is 150 north. What's my change in position? What's my displacement? Just 100 meters south, 150 north. Are they locations? Are they positions? Or are those displacements? This is where I am. And then this is where I am. Right? Those are positions. It actually says position. It doesn't always use that word, but this time it does. Those are positions. So how am I going to find displacement? Sorry? We're going to subtract this time, right? In the last question, we were given displacements. We add. In this question, we're given positions, so we subtract. So we're going to say displacement is final position minus initial position, which is, what are we going to say, 150 meters minus 100 meters? Is that right? Wait a second. I got a north and a south in here. If we make north positive, then shouldn't this be 150 minus negative 100? Is that okay? What's that, 150 minus negative 100? That's 250, isn't it? So my displacement is 250 meters. Oh, it's positive. That means it's to the north. What's my change in position? It's the same thing, isn't it? That's what we define displacement as, is change in position. Anybody know what the distance would be here? It would be 250 meters. Distance and displacement will always be the same number unless you change direction. I don't mean like you're north and then you're south, but if I walk north and then I turn around and walk south, then distance and displacement will be two different numbers. But if I keep walking north or I keep walking south, if I'm not changing the way that I'm moving, the two numbers will always be the same, just the displacement will have a direction, distance won't.